The Western Cape government and the city of Cape Town are driving a multitude of pioneering housing projects. Now, this is all to address the spatial planning legacy left behind by apartheid and to create integrated communities. One such example is the Conradi Better Living Model. This 3 billion rand development is close to the Cape Town CBD on the 22-hectare government-owned Old Conradi Hospital site. A knock-on effect of this development will be the upgrading of surrounding roads, infrastructure, and public transport. This initiative will provide 3,602 residential units, 1,764 of which will be grant-funded. The rest will be for the open market. This will help hard-working people of our city, such as policemen, teachers, and nurses. The fact that it will be situated close to public transport means that workers in the surrounding areas can live close to their place of work. The development will include retail and commercial spaces, community facilities, and parks, which residents from surrounding communities will be able to enjoy. 2 brand new schools will also be included. This development is expected to provide over 4,300 jobs in the operational phase and just over 9,300 jobs in the construction phase. The Conradi Better Living Model will serve as a blueprint for how we can unlock the economic potential of state-owned property in the future. Concrete proof that the Western Cape government and the city of Cape Town are hard at work changing the game of affordable housing. Better together.
Phase A consists of the Forest Drive intersection widened to provide 2 lanes per direction, as well as to remark and widen Forest Drive extension between Mutual Road and Mupin Road intersection as a 3-lane cross-section. Phase B. The key transport infrastructure project to accommodate the development is a road link across between Forest Drive extension and Voortrekker Road across the Northern Railway line, known as the Aerodrome Road Link. Estimated future water demands for water and sewer lines enables the civil engineering contractor, in this case Martin and East, to determine the trench depths, the trench widths, the size of the piping, as well as the scope of the work by the engineer. Site clearance BOQ Item 2.2.1 Clear and grub site complete and dispose of material as described in project specifications including grass, parking areas, SANS 1200 C8.2.1. This clause states that any material obtained from clearing and grubbing shall be disposed of according to specification and project or any suitable location specified by the contractor. This item is measured in hectares, kilometers or meters. Item 3.2.1 Excavate in all materials for trenches, backfill and compact, including dispose surplus unsuitable material, for pipes, up to 350 mm diameter, for depths, over and up to 0.5 meters to 1.5 meters. SANS 1200 DB 8.3.2a, excavate for all materials for trenches, backfill, compact and dispose of surplus material. Items will be provided for various pipe diameters in steps not greater than those specified in 5.2 and various depths in increments of 1.0 meters, measured to the bottom of the bedding layer. Differences and similarities. Pipe diameter specifications of 5.2 are different as applies to the specifications in item 3.2.1, and not in accordance with SANS 1200 DB 8.3.2a. Trench depth measurements are grouped into increments of 1.0 meters and is in accordance with SANS 1200 DB 8.3.2a. Unit of measure. M in accordance with SANS 1200 DB 8.3.2a. Item 4.2.1 to 4 Excavate in all materials for trenches, backfill and compact, including dispose surplus unsuitable material. Electrical and irrigation ducts at road crossings. Depth range 0 meters to 1.2 meters and trench widths. A. Up to 750 millimeters wide. B. Over 750 millimeters up to 1000 millimeters. Comms ducts, trench widths. A. Up to 1.5 meters deep. I. For up to 2 pipes. E. For 2 to 5 pipes. SANS 1200 DB 8.3.2 Excavate for all materials for trenches, backfill, compact and dispose of surplus material. Items will be provided for various pipe diameters in steps not greater than those specified in 5.2 and various depths in increments of 1.0 meters, measured to the bottom of the bedding layer. Differences and similarities. The units of measurement stipulated by SANS 1200 DB 8.3.2a are meters or meters cubed, and likewise item 4.2.1 to 4 is measured in meters. SANS 1200 DB 8.3.2a states that the pipe diameters have to be mentioned. However, item 4.2.1 to 4 does not specify any pipe diameters. According to SANS 1200 DB 8.3.2a, trench depths are supposed to be in 1.0 meters increments, but item 4.2 states that the depth range is 0 meters to 1.2 meters. Item 6.2.1 and 6.2.2. Roadbed preparation and compaction of material. Compact to 93% modified Oshto maximum density, 100% for sand, in situ G8 layer. A. All roads 300 mm in situ. B. Sidewalks 150 mm in situ. SANS 1200 DM 8.3.3a. Treatment of roadbed. A. Roadbed preparation and compaction of material to 1. Minimum of 90% of modified Oshto maximum density. 2. Minimum of 93% of modified Oshto maximum density. 3. Minimum of 100% of modified Oshto maximum density. Differences and similarities. All descriptions are in accordance with SANS 1200 DM 8.3.3a. Unit of measure. Cubic meters in accordance with SANS 1200 DM 8.3.3a. Additional information was provided as they subdivided the layers into road and sidewalks, as well as adding the in situ thickness. This is above and beyond the requirements of SANS 1200 DM.